Okay, each of the graphs in this what to do section is going to start with the same table, the parent function for the absolute value. We know if we take the absolute value of -2, -1, 0, 1, and 2, we get 2, 1, 0, 1, 2. And so we're not going to have to do a lot of tedious plugging in anymore. Now we're going to look at this function and we see the only change is a -2. Remember, -2 means a vertical translation down 2. So instead of starting at 0, 0, we're going to start at 0, -2. So that's where the vertex of this absolute value graph will be. Now the next point in the list is supposed to go 1 to the right and 1 up. The next one goes back to the vertex and goes 2 to the right and 2 up. So now I can see that this is going to continue up in that direction. Looking at the other side of the absolute value, I'm supposed to go 1 to the left and 1 up. And then 2 to the left and 2 up. And I can see that that's going to continue in that same direction because we know that all absolute value graphs make this nice V. I'm always at least going to label that vertex, preferably more, but at a minimum the vertex. Looking at the next one, I see that there's a +3, but that it's inside. And I know that I always want to think of that as being the opposite of what I see in the problem. So I know that this is really going to translate left 3 spaces. But it's coming from the same parent function that we used a moment ago. So if I start 3 to the left of where I was, but then I go to the right 1 and up 1, to the right 2 and up 2, and I continue in that direction. I go back to the vertex, I go to the left 1 and up 1, to the left 2 and up 2, and I continue in that direction. I can draw my absolute value graph. Didn't even have to make a new parent function, but I definitely want to label that that vertex is at -3, 0. Now my next graph has a stretch, and anytime I have a stretch, I like to actually make the table again. But it's the same table, so -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. But I'm looking at this and I'm like, wait, I've got to take a third of stuff. And most of my numbers are not divisible by 3. So instead of picking those numbers, I might actually go back. I'm going to pick -6, -3, 0, 3, and 6. It's going to make life a little easier. So the absolute values are still simple. But now when I multiply all of these by a third, it's going to be easy to do. A third of 6 is 2. A third of 3 is 1. A third of 0 is 0. A third of 3 is 1. A third of 6 is still 2. Okay, but I also see another transformation. This thing is translated down 4. So I'm going to start down 4. But instead of going 1 to the right and 1 up, I'm going to go 3 to the right and 1 up. And then back to the vertex and go 6 to the right and 2 up. And then the same thing happens on the other side. I'm going to go 3 to the left and 1 up. And I'm going to go 6 to the left and 2 up. And I can see that my absolute value graph looks like this. I'm going to label 0, -4. I might even make it a point to label one more point there since this slope is not the usual up 1 over 1. One more along these lines. I can see that my absolute value graph is going to be reflected across the x-axis. That's what that negative does in front of the problem. But it's also going to be translated up 4 spaces. So I'm going to start by translating up 4 spaces. Now normally I would go over 1 and up 1, but I'm going to go over 1 and down 1 because it's upside down. And then I'm going to go back to the vertex and go over 2 and down 2. And I can see that I'm continuing in this upside down direction. And the other side looks exactly the same except the mirror image. So my absolute value graph looks like this. And I make sure to label that vertex. Next, we want to imagine writing equations just based on the translations. Okay, so if we translate 5 up, well, 5 up happens outside the absolute value. So that equation would just look like this. 3 down is also outside the absolute value, but it's negative because it's going down. 6 units to the left, here's where we need to be really careful, right? This is side to side. So that means inside. Now I always want you to start with x minus. So if I'm going to the left, that's like x minus negative 6, which is going to look like y equals x plus 6. If you don't want to start with the negative in there, just always tell myself side to side is opposite. So left is going to be a positive. Right is going to be a negative. Now let's get a little complicated. 5 units up and 2 units to the left. Okay, 2 units to the left is inside. That's a lot like what we just did a minute ago. So I'm going to have an x plus 2 on the inside. But then 5 units up is on the outside. So we have y equals the absolute value of x plus 2 plus 5. Next, we have 3 units to the left and reflected over the x-axis. So we're cheating a little bit here. This says translation. It could have just said transformation because we're adding a transformation in here that's not a translation. If I go 3 units to the left, that's an inside thing. I'm going to have x plus 3. But remember, when we reflect over the x-axis, we do that because of a negative in front of the problem. So we've built our problem.